Hi, welcome back to Elasticity. Today we are going to talk a little bit more about bodies and motion. So last time we saw what is meant by a body and how to use inequalities of the form fi of x comma y comma z equal to 0, is less than or equal to 0 to represent bodies. This class we are going to see how to represent motion. So what we do is we represent the motion of a body by listing the displacements of each particle in the body as a function of time. Now, if you had only a few particles, then you could number the particles 1, 2, 3 and so on. So what we need is, for this to occur, we need a way to label the particles. So what we do is we label the particles by their locations at time t equal to 0. We can get cute about this and say we can talk about labeling their locations at other times or something like that, or by labeling an abstract location and so on. We will not go there. We are always going to say initial locations form the labels for the particles. To give you an idea, this is like labeling particles by their address. So what I mean by that is, if you are sitting in a classroom, instead of calling you by name, I just say the person sitting in the 3rd row 4th bench. That kind of thing. You see what I mean? So I am labeling the particle, I am labeling you based on where you are sitting. And then I can say move to 4th row 6th bench and so on. Okay? That move to is represented by a vector. Okay, which is called the displacement vector. So I am going to say the displacement u of x comma y comma z as a function of time equals u1 of x comma y comma z in the I direction plus u2 x comma y comma z comma t in the j direction plus u3 x comma y comma z comma t in the k direction. Of course, I am using Cartesian coordinates for this. Until I state otherwise, we will stick to Cartesian coordinates for quite a while. We can do the same thing for other coordinate systems. So what do you need now? You need, first you need to describe body, so you need origin, then you need axis, then you need coordinates, then you need displacements, as a function of time, right? So the verbal meaning of this displacement is that the particle which was at x comma y comma z at time t equal to 0 is displaced by the vector u of x comma y comma z comma t at time t. So to draw your picture, here is my coordinate system, here is my particle. So this is xyz. My displacement will take it and move it somewhere here. And as u changes with time, you can see that the particle which starts out here will slowly kind of go out there. And remember, in our definition, u of x comma y comma z comma time t equal to 0 must be equal to 0, because at time t equal to 0, the location of the particle is the way in which we are labeling. So you better not have moved at time t equal to 0. Okay, so that's how it works. So let's look at an example. So the body is a cube. The origin is at a corner of the cube. The axis are along the edges, and the coordinate system Cartesian. You better list these three things before you can describe a body. So here it is. You can see the cube. Okay, that's the cube. And to be definite, let us say the sides of the cube are 3 units long. So it goes, the cube is defined by particles in the cube, satisfy x lying between 0 and 3, y lying between 0 and 3, z lying between 0 and 3. So now I have defined the body. Next step, let us say my displacement is given by u1 equal to 3ty, u2 of x comma y comma z comma t equal to 0, u3 of x comma y comma z comma t equal to 0. So what does this mean? It means that the particle is moving in the x direction or moving in the x direction the rate at which they move depends upon their y coordinate. Notice motion is in the x direction, but the dependence is upon the y coordinate. So what will happen? Let's pick this point. This is 0 comma 0 comma 0. It's going nowhere because y is 0, this is 0, that's 0, it's going nowhere. How about this point? This is 0 comma 3 comma 0, and you will see that it will be displaced. Y is 3, so 3 times t times y, so it is going to go in the x direction by an amount. Let us say after 1 minute or 1 second it will go to 3y. So I mean 3, so it will, what used to be at y will move in the x direction by amount 3y. So 3 will go to 9. So it will go like that. The distance through which it goes is 9. You will see that every point along this line will move by the same amount. So this will go like that. This will not move at all because y is 0. These points will move, so you'll get like that. The vertical points will not move at all. These points will not move at all. This whole plane will not move. I don't know whether you can see, but this will be sheared. I can show you better in the xy plane. So what happens is, this is x, this is y, this is top view, and the particles that are y will move like that. So things will go there. What used to be a rectangle here will move. So things will become a parallelogram. So a rectangle becomes a parallelogram. That's how motion occurs. Okay, by using the displacement vector. Thank you.